here again with Philip Lewis, the Director of Research for Intelatus, to help break down the recent and increasing noise heard around the notion of nuclear power for commercial vessels to help ship and boat owners reach new and increasingly strict emission targets. So, Phil, as always, we appreciate having you on. So, I'd like to
Thanks,
start
Craig.
off with a simple question on nuclear as a potential power source in maritime. Quite simply, why are we even talking about this? Why are we interested?
Well, you're right. There is well, sorry, I should say first of all, thanks for having me back. You are right. There is quite a lot of noise around this. It, it's not like we haven't had noise around nuclear for some time. I mean, there have been commercial nuclear vessels. There's been a US commercial nuclear vessel. There have been um, historically other initiatives in commercial nuclear maritime. But generally, these have been based on military grade technology, which is basically just dipping into the technology side. They're pressurized water reactors, which are noted for when they fail, they tend to fail in quite a spectacular way. That's where you get the 3 Mile Island, the Chernobyl, the Fukushima. These are all the things that are in public consciousness. And so I'd say there's um, always going to be uh, some concerns about the adoption of nuclear, and then also the technology was generally, as I said, military grade and therefore linked to the military nuclear navies. Um, what we've seen recently and why there's been a lot of news is reactor technology is developing, changing. We talk a lot about the energy transition at the moment. It's a current theme, and I guess everybody's looking for that silver bullet of, well, if it's not coal or if it's not oil and gas, it's got to be wind or it's got to be solar or it's got to be nuclear. Well, I think most people, most rational people, recognize there is a blend of many different technologies that are required. Um, the attraction of nuclear power is its baseload capacity. It's very reliable when it works. You plug it in and it basically operates. And it operates at generally high capacities of electrical output and, interestingly, thermal output. It generates steam. And in a maritime operation, steam is also quite interesting. So there's a bit of interest there. What I would also bring onto that, and we can deal with this maybe going through the discussion, is there are now technological developments around generations of nuclear technology design. These generational developments, and particularly what's called as the Generation 4 reactors, have set up rules around making nuclear technology sustainable, low waste, because people are always worried about dealing with the waste from these things, proliferation resistant, so to minimize the risk of nuclear waste being or nuclear materials being repurposed for military or terrorist activities. Safe in that if they're within population areas, that if they fail, that there will be no fatalities or long-term impact to life. And quite importantly, low cost. And so there's quite a lot of development in that. And because of that, that's opening up the avenues in the maritime segment.
So for anyone watching who is interested in the topic, can you just give us kind of an overview of where we are today?
Well, I think if we look at where we are today, let's look at who's actually doing something about it at the moment. Maybe we can answer it that way. The world leader is Rosatom from Russia. They are head and shoulders above anybody else. They operate an increasingly large fleet of icebreakers. This will be their third or fourth generation of icebreakers. So they've had vessels from the 70s that have already decommissioned and been decommissioned and left the fleet. The latest generation of icebreakers generally feature 275 megawatt thermal reactors. So that's over 300 megawatts of power installed on board a vessel, which is a substantial amount of power. to have installed on a vessel. They have a cargo carrier, they have floating nuclear power plants, an operational floating nuclear power plant already, and they're building a series of others to operate, provide power to remote mine areas in Russia. And their technology is very much pressurized water reactors. So they effectively extensions of the military programs. So with the Rosatom reactors, if where they sell commercially or where they look to sell, for instance, floating nuclear power plants commercially, those power plants will need refueling probably every 5 to 7 years. And when they need refueling for quite a long time, but they are not refueled in situ. They're brought back to Russia. This is a commercial model. It's not actually in practice at the moment, but that's a commercial model where they are refueled in a safe environment, in a secure and safe environment within Russia. Obviously, for the operator of that facility, that means they've got a hole in their capacity. So usually what we see at the moment, and the one project, the mine project, for instance, they need 3 of these power barges. They're actually buying 4, of which one is the reserve power barge. So effectively always there for if there's one that needs maintenance or one needs to be pulled back to base for refueling. So that's some of the drawbacks there with that, but that and that's also a bit of soft power influence there. Rosatom with its land-based reactors is an extension of foreign policy, as large industrials often are. And part of that foreign policy is getting goods and services back into Russia. And nuclear technology is one of those areas where that happens. The Europeans, if we look at people like who have been in the press regularly recently, Core Power, for instance, or Seaborg from Denmark, they're adopting these Gen 4 reactors, and particularly a technology called molten salt reactors. Their advantage is, well, they're Gen 4, so they meet those criteria we mentioned earlier. You build them in a factory, and effectively you build them as a battery. You build them for a long operating cycle, 20 years, 30 years, where you do not refuel them. And that means you do not tamper with them. So you do not get your chief engineer going in there and playing, or chief reactor officer playing around with the reactor. They are a battery, if you will. They're sealed up and left where they are. If they fail, in theory, the ship is safe, the crews are safe, there is no explosion risk, there is no radiation risk. If you want to refuel, you effectively replace the battery. So they are developing that for floating power plants, low emission fuel production, and things like desalination, amongst others. Desalination, anything where you require lots of not just power, but temperature, high temperature. Nuclear reactors are very good. They produce very high temperature. So that's very good in chemical reactions and also things like desalination. Now, the Koreans, if we look at those, Hyundai and Samsung Heavy Industries, for instance, 2 of the large sort of maritime contractors, they're looking at initially at things like power barges, floating power plants. But longer term, there's a real interest in nuclear power container ships with these Gen 4 molten salt reactors. Now, for those container ships to work, that's the reason why container ships, well, one thing, they're about speed. They go at high speed. Fuel's obviously a big issue for those vessels. Emissions are a big thing for those vessels. But what you can look at is they go port to port. They don't tramp around different ports. If you're going from one port to another, if both ports agree to the rules and the procedures around dealing with nuclear vessels, that makes it more realistic a scenario to look at that. But that doesn't then encourage you to build 50, 100, 150 vessels. We're talking vessels for the route. So there's obviously some way to go there. And I think it's really the floating power plants where you'll see things happen first, and probably the low and zero emissions fuels production. When we say low and zero emission fuels, we mean methanol and ammonia, things that you can basically hydrogen-based fuels that you can produce from desalinated water offshore, where the product can be stored in a floating production storage unit and offloaded with technologies that are available and currently known today. Chinese commercial yards are also developing pressurized water reactor solutions rather than Gen 4 water solutions. And that's really for their domestic oil and gas operations, decarbonizing those operations, and also as part of potentially a more geopolitical policy of expanding influence in the South China Sea, of having power barges within the South China Sea. That program seems to have gone a little quiet, but there is quite a lot of high level analysis going on to see where that program really is, and where we see it in the commercial space versus the almost sort of extension of government policy. Japanese, for instance, they're also looking at both fission and actually fusion reactors for container shipping. Again, the idea is these long-term shipping routes, minimum refueling, high speed. So but these are all very much at the early development phases of what's being discussed.
Now that we know where are we heading? And I guess, how does all this fit in? Because obviously the IMO has their strategy to be
Mm.
net zero by or around 2050.
The IMO strategy is it's about performance indicators. How you get there, it's really up to you. You can run sails on your ship, and people are looking at wind-assisted propulsion. Going back to the old days of sail. You have low and zero emission energy carriage, dual fuel engines, methanol, ammonia. The challenge there has always been the availability of the fuels. LNG is being used as a transition fuel today, although methanol is increasingly important. In short sea shipping, we see a lot more batteries, a lot more hydrogen. It really depends on your application. And nuclear potentially is part of that longer term solution. People recognize today alternative fuels are not in place and the alternative engines are not in place, and the financial conditions aren't in place to retool the whole fleet and resupply it with all these fuels and technology. But it's a balance of all the technologies at the moment to lower your emissions, route planning, hull scraping, changing a propeller, changing the bow, hydromechanical design as well. So it's not just all about fuels and the energy carriers and the energy conversions, but nuclear does play a part, sort of long term, potentially in the ability to support the generation of those low emissions and zero emissions energy carriers. But again, we're not going to see one in the water in 2 years or 3 years. This may be for the 2030s, 2040s.
One final question, and you've already addressed some of the challenges. Obviously, finance,
Mm.
security comes to the fore, but can you look cumulatively and just give me a succinct look at what you see as the chief challenges to nuclear and commercial maritime becoming a reality,
Yeah,
or a bigger reality, I might say.
yeah, I put these maybe at three sort of high level factors. The cost profile. Nuclear has generally got high upfront cost. It's very capital intensive building. Um, the idea is you have lower operational costs, so your whole life cost might be lower, but you have to have the ability to finance that high upfront cost to get the benefit of the tail. And that doesn't necessarily sit with the investment appetite of most, say, shipping investors. So that's, I think, a challenge, and that's linked to the whole finance challenge. Regulations, international maritime, as well as local regulations are required for the whole supply chain. And they're not there yet, not really. Bits and pieces, but we've still got a long way to go. And public perception, nuclear appears to be generally regaining public favor. But what happens when a nuclear powered commercial ship arrives in a busy commercial port near you? We generally see that there are people like the idea of low emissions, zero emissions until it's in their back garden.